Good morning, everyone. Thank you for taking time this Friday morning to join us for the Team Research Forum. This is our first session of the fall, so we're very excited to have a big group of people joining us. So to get us started this year, we decided we wanted to take a look at HPC, and we've received throughout the year a lot of questions around computing resources on campus. So this morning we have a group from the High Performance Computing Core. We are going to talk about what resources are available, how to access them, and then we're going to take some questions from the audience at the end. I just want to remind everyone that for the best enjoyment of this forum, we invite you to keep your microphones muted and your video off. And then we can have an opportunity to unmute microphones and have a Q&A at the end of the chat. If you have any technical issues, please feel free to send a private message to me or Shelby, who's one of our co-hosts. If you have questions in the process of the presentations, please feel free to post them to the chat box and we'll be monitoring that for your questions. So with that, I want to welcome our speakers. We have Charles Bookman, who is the technical director of the UC Davis HPC core facility. We have also with us Dr. Carl Stammer, who's the executive director at UC Davis Data Lab. And we have Associate Professor Dr. J.P. Graff, who is the director of clinical informatics at UC Davis Health. And to get us started with today's session, we are also welcoming Dr. Ian Corp, who is the Associate Director of the Bioinformatics Core at the Genome Center and the Chair of the HPC Advisory Committee. Thank you for joining us. I'm going to go to the background and let Ian take on.
Hi, everybody. Today I want to give you kind of start off with a really an overview of things. So let me share my screen and all right. How does that look for everybody?
Looks great.
All right, thanks. All right. So one of the things you'll notice first thing about this slide deck is it's just black and white because, one of the things you have to learn about computer people is they're probably terrible with art. We have like, coder art. That's why this looks like it is. But I want to answer a little bit about what the heck is research computing anyway. So I'm going to start off talking about the different kinds of computers that we use every day. And a lot of these can be used for research. You can use a tablet, even your phone. It can be a research computer of sorts. And you have things like laptops or desktops, or sometimes people call a workstation. And you have things like computers that are connected to particular scientific instrumentation. And then you have the high performance computing cluster. So, and we have several of these kinds of things on campus. So this is what really we're talking about today. And I wanted to just introduce why is this slightly different than some of the other things that we use. So when you're using a tablet, pretty much of the work you're doing is actually in the cloud. And you use your tablet locally, you're using your fingers on it. The storage is usually in the cloud, although sometimes there's a tiny bit on the device, maybe it's photos or whatever, but then they're uploaded to the cloud. And there's a lot of stuff that might be working with, which is actually cloud-based, and the tablet doesn't have to do much. It's just kind of an interface to what's happening in the cloud. Once you start working with a laptop and then later into a desktop, more and more of the stuff is happening on the actual computer. There's still a lot these days that's happening, more and more of stuff that's going towards computing in the cloud. But sort of historically, there's a lot of that used to be done on desktops, and people would buy more powerful desktops to get their work done. But so many things that are happening today are in the cloud that maybe more powerful desktops are not even that important. And a lot of people just have their laptop connected to a couple of monitors. And so desktops are being sort of de-emphasized. But sometimes you will have a very, very powerful desktop, and people will call that a workstation because it's got many, many gigabytes of RAM or terabytes of storage or something like that. And so you're starting to do more things kind of on the local computer. Scientific instrument computers is another one we might be working with. And, they're worked with on site at the machine. The storage is usually local-ish, meaning the machine itself is going to do some of the storage and maybe even data reduction and stuff like that. But it might be that there's so much, the size of the files are so large that they actually can't store the stuff. And so they're actually, the storage is being connected to some nearby HPC. So this is like at the Genome Center, we have a lot of things that look like this. And there's other places on campus where we have scientific instrumentation that needs to be connected to some kind of storage that's not too far away. Once we get to HPC kind of cluster, one of the big differences is that our access to that is remote. Really, nobody stands in front of this thing and has a keyboard and a mouse attached to it. That doesn't really happen. We're connecting to it remotely. But lots of the things that we're doing on it are happening there. And HPC clusters, I mean, you can think about them as we have them on campus. And so they're like, oh, they're UC Davis, but it's not really different to connect to something like this than to connect to Google Colab or to other kinds of cloud services where you connect there, you do your work, and you're doing it sort of there on that machine. So HPC cluster access, usually like there's two sort of standard modes. There's the old school way of using SSH to connect, and there's the sort of new way of being able to do something that's what we call on-demand computing. And not all clusters support on-demand computing because it's kind of a new thing. So let's just talk a little bit about what it means to do on-demand computing. So you might run RStudio as part of something that you do a lot. And some people might run this on their desktop or laptop, some kind of workstation environment. But an on-demand version of this is it looks for all the world like you're using your desktop computer to run RStudio, but actually everything is running over on the cluster. And this is just sort of a portal to what's running here. So why would you do this? Well, because you have access now to a huge computer with maybe, 256 CPUs in it instead of 8, and a terabyte of RAM instead of 16 gigabytes. And so it's much more powerful if you use your computer as just sort of a portal to over here. And so on-demand computing is becoming very popular. And we also might call that dynamic computing or live or something like that. But it's this idea that it looks like you're using your own computer, but you're in fact not. And this is one of the resources that we are trying to advertise more because it probably lowers the barrier to entry. One of the things about research computing is that it feels like there's a wall between you and being able to do it. And part of that is because of things like the old school way of doing it, which is, for example, SSH. So secure shell is a way to connect from one computer to another. Like you can go and drive this cluster with your laptop or anything else. But it's a little bit unfriendly. It's not like a point and click environment. We like point and click environments. We use them all the time. And it doesn't really matter if you're using a Mac or using a PC or you're using a Linux machine. They all have very similar desktop environments these days. Like the Mac interface and the Windows interface don't really look that different. And when you go over to Linux, the difference between Linux is there's 20 different graphical user interfaces, some of which are designed to look exactly like Windows, and some that looks like Mac, and some things that look different. But they all have a kind of a point and click interface, and it's all designed to be intuitive so that you can interact with it in a way that's sort of most convenient for most people. But when you get to working with clusters, people tend to use more the command line interface. And so a command line interface means you type. This is actually my picture of my terminal. Like if I open up the terminal application on my Mac, this is what I would see. And I would start typing commands here. Like, really, you type? Isn't that old fashioned? Why are we still using the CLI in 2024? It sounds like a crazy thing. Well, here's one reason. If I wanted to throw this file into the trash, I would like click it and drag it into the trash can. That might take me a few seconds, 5 seconds to do it. I can also type this in 5 seconds. And this just saved 532 Zoom chats and put it into a new file. That's why we use the command line, because we can do powerful things and automate things much easier. It's much easier to say, do this and this and this in sort of an automated way than like clicking and dragging things. So everything that you do on your computer that involves clicking and dragging or double clicking or whatever else can also be done with a command in a terminal. You can type it, and it's much easier to automate those typing tasks than it is to automate move the mouse pointer to here and click and drag and stuff like that. So that's the reason why is the CLI is still relevant, is because it's more automatable. So HPC clusters speak Linux. Linux is free and it's secure and it's open source. And because of these things, it's the usual choice for HPC clusters around the world and also on UC Davis campus. So if you want to drive our clusters, you have to know a little bit about Linux. It's and it's not that bad. If you can understand how to run your desktop environment, you still use your desktop environment. Just like let me give you an example of a command that would work if you were using a Mac. If you double click on a file, that's also the open command. You just say in the terminal, open this, and it's like double clicking it. It's not that different. So here, just let me summarize what the research computing means, sort of often means. It usually means Linux and a command line interface, and it means connecting from your computer to the HPC cluster, and having to learn some unfamiliar concepts, but in doing so, you'll become a more amazing human being. So I'm glad that there are people here that are interested in research computing, and I'm hoping that this is just the first of we think that we recognize that HPC is starting to become pervasive in lots of different fields, and so the people here are sort of at the beginning of a wave of lots of new computing that's going to be happening across campus in lots of different fields. It's not going anywhere. I didn't even touch on a lot of the important concepts that go along with this, like what is GPU computing, like what does backup look like in these kinds of environments, and these are things that we can either address in the the question and answer period later, or maybe some of the other speakers will be addressing these things. And with that, I'm going to turn this over to Carl.
All right, thank you, Ian. I am going to share my screen and hopefully it will get the right one. Let's see. All right, is everybody seeing a slide deck?
Yes,
There?
and it's
Perfect.
the right one.
Okay, so I'm going to pick up where Ian left off and hopefully address how you can get through some of that not so bad changes that he discussed to actually get online and start using the HPC. So for those that are not familiar, why will not my slide deck change yet? If there are people out there that aren't familiar with Data Lab, very, very quickly, we're a data science support unit on campus. We partner with people on research engagements. We also provide a ton of training in different areas of data science practice and techniques, one of them being HPC itself. So we have a growing amount of training materials and workshops in this area. And the first thing I want to just point to is just let everybody know, for those that are interested, this quarter we have 3 related different workshops that we're offering this quarter on November 6th. And Ian was talking about the command line interface. For those that want to become more amazing human beings and you don't have to have any experience with that at all, we have an intro to the command line workshop that actually I will be teaching that one on November 6th, where we will start from nothing and get you all the way through basic command line skills, the most common commands, also pointing you to other places where you can continue to grow and learn. And one important thing we will cover there is also SSH key management. Ian talked about SSH as the security protocol that we use in HPC for those that are working in the command line area, and we will cover that there. Right after that, November 14th and 15th, we're doing it's a 2-day, all day, so recognize that it's a big commitment, but this is a very in-depth introduction to working on the HPC at UC Davis. And as part of that workshop, we will show you how to get your account set up, get you onboarded, and takes you all the way from 0 to 120 miles an hour on those systems, everything you need to do in that command line world, right? So this is and that's why this one does have a prereq. You either already have some command line skills or you take the workshop before this so that you can be successful in this course, because this 2-day course will focus on that heavy command line. So that's that. Then we are also offering on the 18th another workshop that is the on-demand version of that, which Ian mentioned. So you don't have to have command line skills. I think it's still helpful, but it's not prereq for the course there. And that is also an all-day course, but same thing, we will take you from 0 to full speed in that workshop, help you, take you starting with get your account set up, how you get on. If you don't already have, and we'll talk all about the different tiers of structures. You're going to hear more about that later today, the different clusters that are available to you on campus and what that access looks like. But we will be able to get you on the system and using on demand in that workshop. So we have 3 in person. All of these will happen in the data lab. We're on the 3rd floor of the Shields library, and they are in-person workshops because hands-on-y stuff just works a lot better in person, where we can have, various helpers when you run into a problem and keep things moving along. The other thing I want to point you to are some resources that we have available. So the first QR code goes to, we maintain an index of all of the training materials for our various workshops. And that index, actually, let me I'll drag it over here. Oop, that didn't work. Looks like this. And if you go under basic computing, you can see from the last time that we taught Introduction to Command Line and Remote Computing, you can see all of the course materials for that. There are links to videos from the last time we taught it and all that. So you can also serve as a really important self-serve resource for people that want to, attack this on their own and have reference material. I also would invite people starting next week. I'm going to emphasize this. We are currently literally mid-transition to our new website, which will have all this, but these links are correct. To go to Data Lab Workshop Training Calendar, it will list all of those different workshops that you can and how you register. It's free for anybody in the Davis community to attend and ongoing. So for future trainings that come up, you can look there. And then I would also point people to the HPC itself, and Charles is going to probably talk about this when he gets there, has their own set of documentation. Sources available to you that are online, in addition to the workshops, to get things going. And I just got a message that my internet connection is unstable, even though I'm on a gigabit hard line from my office to prevent that. So we'll see how this goes. Somebody scream if I lose connectivity. And the QR codes work, and these are the human readable versions of these. And I'm pretty sure we'll distribute this deck all these decks afterwards to people, and the recording for this will be available so people can get back to these. The other point of help that I want to point people to is office hours. So Data Lab office, we offer in-person office hours every Tuesday from 1 to 2 in, again, the Data Lab classroom, which is 3rd floor, 360 of Shields Library, same place the workshops happen. You can, if you're having problems, you can drop in and we will help you work through those issues and get you on the HPC and make sure that your jobs are running and help you out there. We also do every Monday virtual collaborative office hours where whole groups of us from the Data Lab, from the HPC, from Stat Lab, CTSC Biostatistics. So it's a much larger group and it's virtual, and you can come to those on Zoom and get help. In each of these cases, you'll get directed to the best person to help you with the particular problem that you have, to make sure that you can successfully get onto the HPC system and, again, run your jobs and make everything work. So with that, I believe that's the end of my training part. Hopefully all those resources are useful to everybody. And again, I would encourage you, if you ever have any question or something you want to get to, you can always go to the just Data Lab website, datalabucdavis.edu. And let me stop my screen share. And then Charles is going to take over from me next, and he is going to dive in and really talk about the nuts and bolts of the different clusters that we have and give some demo, I believe. So with that, I will turn things over to Charles, unless there were any questions I missed. Charles.
All right. Thanks, Carl. So yeah, I'm going to give a little deeper introduction to specific HPC computing. And so I'm going to attempt to share my screen. And let's see. And you all can see that fairly well, I'm assuming. Real quick, again, my name is Charles Bookman. I'm the technical director of the High Performance Computing Core facility. I have a background in education and system administration and been at UC Davis for about 11 years now. I've been with the High Performance Computing Core for about a year and a half, started in January last year. I wanted to give kind of a larger overview, and my team is comprised of essentially six system administrators and architects, and well, 8 employees total. So we handle 11 clusters on campus. And we have 2 clusters in academic surge ran by College of Engineering. We manage the Genome Center cluster, LSSE0, and Watershed Sciences building. We manage Franklin and Atomate. Franklin is a cluster ran by CBS, Biological Sciences. Atomate we run for School of Medicine. And in the campus data center itself, we manage Farm for College of Ag, and Demon for Letters and Science, Peloton for Letters and Science, Cardio for School of Medicine, and currently we manage Impact for Letters and Science. And just about 2 weeks ago, we came up to speed with our own cluster for HPC, which we've called Hive. And typically each cluster has been brought up either by the school itself or by a group of principal investigators. So if you're associated with engineering or computer science, you might want to look into HPC1 or HPC2 for moving forward. If you're affiliated with Genome Center, then you would typically go to LSSE0. Biology, you would typically go to Franklin. And so that's typically the method, how things used to work. Clusters now are, well, we're centralizing them. So you both have less choices in the clusters that you will be able to access, but more choice in that a lot of the clusters now are opening up to a wider audience. So for instance, I'll talk about sponsored tiers. So right now, Farm has a sponsored tier for anyone at UC Davis. So if you want an account, I can show you how to get onto Farm. Hive has a sponsored account for anyone at UC Davis. And if you'd like a sponsored account, if you're part of Letters and Science, then you can apply for an account on Peloton. And we handle, I would say, over 700 to 800 different nodes on campus altogether. We have over 20 petabytes of space that we manage. Keep in mind that we don't allow sensitive data on our clusters. So if you have P1 or P2 data, according to the UCOP classification guide, then we can accommodate that. P3 and P4, we are not set up to do that. IET has a solution, and I believe that UC Health has a solution, and we can talk about that. And because I'm on Zoom, this is my floof, and her name's Lexi, and she's clawing my leg right now, so if I scream. How do I get started with high performance computing? So like I mentioned, what you would typically do is you would ask a PI to get involved. If your principal investigator or group has an allocation right now, then you can apply for an account on those clusters. If you're a PI with a grant that is looking to get involved in a cluster, there's many different clusters that you can become a part of. And so we can work with you on getting onboarded, to get an account on board some of those clusters. Right now, most of them subscribe to the condo model, in which case, essentially they are groups of nodes purchased by each individual PI with their grants and just laid on top of each other. So if you're part of engineering, you have not only your allocation that you've purchased, but you also get an allocation of all unused resources across the other clusters. So if you're a part of Hive or Farm and you log in, your group or PI would have, say, maybe 2 or 3 nodes that you've bought, and you'd get priority access to those, but then you'd get access to all the other unused nodes as well. So that's the advantage of having access to HPC. Like I mentioned, we do have sponsored tiers. Right now, if you are interested in getting on board a sponsored tier, we do have a high performance personnel onboarding user portal. And that's a name they came up with at College of Ag. I'm not going to take responsibility for that. It's hippo.ucdavis.edu, pretty easy to remember. And so what I recommend is that people who are interested in getting computing, we do have a sponsored tier on Hive, which is free to get an account. And what I suggest you do is go to hippo.ucdavis.edu, apply for an account on Hive using the public group as your sponsor, and you get access to a public queue worth of resources plus unused resources and a 20 gigabyte allocation of disk space. Same as on Farm. If you go to Farm and select Atom Group as your sponsor, you can also get 20 gigabytes to start off with Farm. Peloton has a sponsored tier for class of letters and sciences. So if you're a member of that college, you can select MPS Group. And once you are approved, then you can get access to the clusters. Like Carl said, some familiarity with Linux is a prerequisite. It's at the end of the day, HPC, it can be daunting. Essentially, it is just a Linux desktop or command line, and you are running Linux commands. So it helps to know how to log in, how to get around, how to view files, how to edit files, how to do basic Linux commands. So I encourage everybody that doesn't know Linux to engage with either documentation or work with Carl on getting at least some basic knowledge of Linux. And how do I log in? Like Ian said, we use SSH as our prime method of access. Along with SSH, that comes in with SCP and SFTP if you want to transfer files back and forth. We do have Open on Demand, and I'm going to attempt to show that off in a live demo. So I'm crossing my fingers. So how do I log in? So I'm going to attempt to, I need to share my screen again, right? Or am I screen sharing? Can you all see my desktop?
Yeah.
Cool. All right. So I'm going to go into Farm, for instance, SSH Farm. And so I'm on a Mac. We're using the Linux terminal. It is not very easy to see because I have it opaque. There we go. So yeah, SSH, we support the terminal. I'm using iTerm2 on Mac. For Windows, we do support PuTTY. We do support MOBA Xterm. There are other software programs we can use, and we also do support Windows subsystem for Linux too. So logging in is easy. Once you have an account and your SSH key is put in through Hippo, Hippo will do that automatically. And so you start off, here's my home directory, C. Bookman at Farm. I have some number of accounts. If your PI has storage, has purchased storage, you get a home directory of 20 gigs, plus you get access to wherever your PI has storage as well. So for instance, I work with Jeff and Jeff has his API and also has home storage. So if I was in his lab, then I can utilize and work with his group on those. Since I'm just in HPC, here is my home directory, and I have 20 gigs. So,
Charles, I'm going to interrupt for just 1 second because I think some people, I've seen a couple of things where people aren't seeing the slides, and I think people aren't used to the new Zoom interface where there's tabs up at the top of your screen. So there's a meeting, and then there's like different things at the top.
Oh, sure.
So if you haven't seen the thing that says Charles Bookman's screen, you might want to click on that so that you can see what he's doing. Sorry.
Okay. So thankfully, I can't see my screen either. There we go. So I want to talk about the job scheduler. And so the job scheduler we use is called Slurm. And for some reason, it is not an acronym that's named after the beverage in Futurama. I guess I didn't name it. So anyway, so we have a job scheduler to take control of all the resources and schedule the resources and manage and mitigate the resources. So if I'm a user and I want to run resources, I do that using Slurm, and then Slurm takes control of all the jobs that I want to run and can allocate those in available nodes and available partitions. So as a member of the HPC group, I have access to certain resources on campus. If I'm in Jeff's group, say, then I can get access to his resources, and Slurm manages that. And so why we like to use Slurm and suggest that is so we don't have users overlap. So I don't take over all the resources on a specific node and have someone else take over all the resources on a specific node and have collisions. So Slurm manages all of that for us, so we don't have to worry about that. And the first thing I'm going to mention is that when you are logging into a system or a cluster, whether it's Farm or HPC2 or Hive, you land on what's called the login node. And the login node is an area where everybody can SSH into. If I type W, it gives me a list of all the users that are on here right now. And so you notice that we have quite a number of users. So please don't run jobs on the login node. So I urge everybody to use Slurm in order to manage all the resources. And what Slurm will do then is we'll take your job and we'll send it to any available resource. Sometimes it might take a while. Sometimes you might be, if you have a large job, it could take some amount of time in order to find where it can schedule jobs where it doesn't interfere with someone else. If you run jobs on the head node, then it takes all the resources from everyone, and then people will get angry and yell at me. So please don't do that. As far as Slurm and the software that we have available, so we have those in what are called modules. And what modules are is HPC maintains a suite of commonly accessed software and scientific packages. And the module command, what that does is it takes information about those software packages and makes them available to your login shell and your environment. So what I'm going to do is I'm going to type in module avail, and can everybody see my screen appropriately, the commands I'm typing?
Yes, we can.
Okay, so thank you. So we mostly provision our applications with SPAC. Here's the all the modules available. So we have rclone, we have AWS CLI if you want to host some resources in AWS. We have Blat, we have Blast, we have BedOps, we have Jellyfish, we have Kraken, and admittedly, I have no idea what these are, but we do offer them. We have Conda, and if I don't know what they are, and admittedly I don't, so if I want to know what Mother is, I do module what is MOTH, so MOTH UR, and it tells me this project seeks to develop a single piece of open source expandable software to fill the bioinformatics needs of the microbial ecology community. So once I find out what that is, this is what I want, I could just type in module load Mothr. And what it does is it adds Mothr and any dependencies into my computing environment. So now I can use Mothr. If I knew how to use it, then I would certainly demonstrate it right now. My apologies, I do not. So I'm done with that. I'm going to module unload Mothr, and then it no longer is in my environment. I could just type in module list, and then it will tell me all the software that I do have installed. And as part of login, we do install Slurm for you, so you can use these commands, and OpenMPI should you want to use that. And OpenMPI is on not all the clusters, most of the clusters, certainly on farm. So now that I have modules loaded and available, and I didn't unload them, there's typically two ways that you can run jobs with Slurm. One is with srun, and srun is a common way to run one-off jobs or interactive jobs. And the other one is through a command called sbatch. And sbatch is more commonly used to take advantage of multiple resources, multiple clusters, and multiples of the same jobs. And so one of the things that I have to know is what sort of permissions and where can I run my jobs on. So if I type in sinfo as a command, then that tells me what nodes are available. And so just sinfo by itself tells me what jobs are up and available, what the time limit is to run these jobs, and the state of the jobs. And so what I want to do is find idle resources or mix or things that are currently not being drained for whatever reason. So this will tell me what nodes are currently in the cluster, with the state they are and the node list. And then I can type a command called shatngr, which is a part of Slurm, show a association user Steve Bookman, which is my login name. And we get this great output that is not very user-friendly, but it does show me what I have access to. Since the cluster is farm and I'm in the HPCCF group, I have all these resources and I have access to these partitions. So the good thing is that there are certain ways to format this that are more readable. So we do have documentation up at docs.hpc, which can help you with this. What I do is I will just do a Google search for Slurm cheat sheet, and there's a PDF with all the common Slurm commands, and any Google search can help you with these commands. So I can find out which account I have access to and which nodes I have access to. And now that I know that, I will try to run I could try to run a one-off with sbatch, and so, or sorry, srun. So I'm going to do srun. I need to give it a time, and I don't expect this to run very long. So this is in days, and you can do days, dash, hours, minutes, 2 minutes and seconds, and then my command. So that Cheeto. So what this does is this is going to take a one-off. This is going to schedule available resources. This is going to find some node that I could run it on and run it on a specific node. So it's queued, it's waiting for resources. I didn't specify where to run it. I'm letting Slurm do this itself. And okay, there's Cheeto. Cats are a hobby of mine, if you haven't figured that out. You can also use srun to run interactive nodes. So say you have something on a specific node that you want to run on. So I'm going to look at the jobs. I see, let's see, I'm looking for specific node, maybe CPU 1066 is idle. So what I'm going to do is srun time, I'll give it, let's say 3 minutes. And I'm going to give a node name of 1066. And I'm going to do a interactive shell with pty bin bash. And bin bash, it was idle. And so what it does is it's reloading the environment. It's mapping my home directory onto CPU 1066. So I'm effectively working on that node with enough resources that I have requested. So this doesn't interact with anybody else's nodes. There's my home directory again. And so I can do, let's say, cat proc CPU info, and I can get all, so I can essentially run jobs on CPU 1066 on a specific node without interfering with anyone else. So I'm not looking at the chat window. Do we have any questions so far?
I would say they're largely being handled by Jeff and
okay. Thanks. So I've exited CPU 1066.
Okay, hold on. Let me buckle up.
All right. So that's srun, and then sbatch is similar. So what I'm going to do is run a command. Look, I've got a program on here, a batch program for sbatch, which I've called batch Python. And so this is a script to take advantage of sbatch. And what I'm doing is I'm calling bin bash. Sbatch is some number of environment variables. And these are placed up top with hash marks. So these are commented out. They have to be commented out for sbatch to see them. So what I'm doing here is I have a script to say I'm just going to use one core with a C, what my runtime is in days, hours, and minutes, my partition to submit to, the max memory that I'm using. Right now I'm using an output. So standard output will be written to my output, job ID, and the any errors I have to the standard error. There are other options you can do if you bring up the man page or go to docs.hpc. There's also commands to mail output, so you don't have to move it to standard out or standard error. You can use email for that. Loading modules, so I'm loading the Conda module, and the Conda module on farm is how I can access Python. And you'll notice Python typically on the operating system will be in bin bash, but since I'm running the Conda module, it puts it in share apps Conda root bin Python, and I can run my program. So what I'm going to do is I'm going to sbatch, and what I'm going to do is list the account that I'm going to run under, and this is Atom Group, which is the sponsored tier, and I'm going to do my the program that I want to run, and then I submitted batch job. It's going to do it's going to run my program for me. The program doesn't have any specific output. It just says hello world. So I'm going to look, and look, we have my errors and my output. So I'm going to do here less my output. Oh, look, here's the output. We loaded Conda and we type hello world. Here's all the information that I have associated with my job. And if this were a real program, you would conceivably get different output in whatever directory you decide to use. Any questions about this? We can also talk about this at the end. Resources are available on Hive. So if you go to hpc.ucdavis.edu/clusters, it gives the available resources for for all the clusters that we maintain. Most modules are available on Hive. We just came up to speed. We just launched about 2 weeks ago. So we are still working on installing a lot of them. Most things work on Hive. R does not currently work. We're in the process of installing that. I also want to see about showing on demand, if that works. And so I can go to armdemand.farmhpc. You can still see my screen, I'm assuming. And then I can log in through CAS. And essentially, this is the same kind of computing without direct SSH in your web browser. So for on-demand, so we have on-demand right now on Farm. This is sort of in alpha/beta. We're still working on some of the bugs. We are putting it on Franklin. It is available on Hive. So we do offer Jupyter Lab, RStudio Server, and VS Code Server, and a VNC desktop. So if I want Jupyter Lab, I can click the link. And so on-demand works just like the command line through Slurm. So it's going to ask you for resources that you can submit it through Slurm. So it asks for the account. It asks for the partition. I'm going to select Hi2 for my partition. We strongly recommend a high priority partition, because if you can submit into a low partition, but it's likely that a Slurm job can be overwritten by someone that has priority access to those resources. I'm going to say I want 8 gigs of memory and 2 cores, and I want it for an hour. If I need any additional modules, I can list them here. And then any specific working directory, if I need a temp directory, I can select that here, but it defaults to my home directory. And if I want to receive an email, I don't. I'm just going to click launch. And then it says, okay, it's in Slurm. Slurm's trying to allocate it. It will, it's queuing it up right now, and it should launch. It's starting. I'm getting all excited. Please be patient, as this process can take a few minutes. And it should work. I'm going to connect now that it says connect. And there I have Jupyter Lab. So I'm pretty happy about that. On-demand also has access to files. So I can do a home directory. Here's everything that I have in my home directory. I can also upload and download files from here to my 20 gigs or to my group drive. So I'm going to upload. I'm going to look for some local file. Here's the presentation I'm working. Here's a crash course. I'm going to upload a file. It's just that easy. It is uploading. Well, maybe not that easy. Okay, there it is. And it's also cool because it's got a file route, or you can see images. So hey, here's my spiffy background image. So I can view images. I can also view the PDFs if I want. I can move files around, create new directories, upload, download to all group directories. I don't have to use SCP or SFTP. And if I want, if I don't like the batch Python script, which I just wrote, then I can edit it directly in the web browser. So if I don't want, say, it to display hello world, I can say, we're all going to die, or, something. Hello all. Save it, and then I can run that specifically in on-demand. Also, if we go back to interactive jobs, and this is the one I enjoy. So VNC desktop, I'm going to assign 4 cores, 4 gigs of memory, and for an hour, I will launch this. And so then I have a mostly fully developed managed Linux desktop. Okay, it's running. Here's the host that it's running on because Slurm allocated the job to CPU 695. It gives me an hour. I'm going to launch the desktop. Cross your fingers. Hey, it actually works. Sometimes it doesn't. We have a fully formed XFCE desktop. And so we have applications, we have the terminal emulator, also a file manager. We have a web browser. We have an Office PDF viewer. Right now it is bare bones. You can install applications yourself, which is good. But if we want the file manager, hey, there's the home desktop again. Through this, you're not going to be able to drag and drop files from your home system or remote systems onto the desktop, but you can use the on-demand to do that. And then here's my terminal where I can run the job again. So I can run the Slurm job. So this gives me a terminal interface, so I don't necessarily have to SSH in. I can use this in the sponsored tier. If I do purchase resources for my group or on Hive, then you get, I think runtime now is 6 months. So I can leave my desktop up for 6 months for all the resources that I have provisioned. Hive has a fair share model, which we have converted into cores. So essentially, we're offering a 8-core desktop with 128 gigs of RAM and a terabyte of storage for less than $300 a year. And so that's a pretty reasonable deal, I think. That is on demand. That's how you run jobs on a cluster. And so I'm going to log out. I'm going to attempt to log out. I can just close this and I can start my slide deck again. So I want to mention after HPC, I want to briefly touch on IET cloud resources as well. And so Aggie Cloud, IET offers an Aggie Cloud Enhanced Secure Enclave. I don't know too much about this. I think they are transitioning from version 1 to version 2. I recommend you go to cloud.ucdavis.edu, I think it is, and find out more information about their Enhanced Secure Enclave. And so what they've done is, I believe that they have made it available for more sensitive information that we can handle on HPC. So I encourage you to reach out to IET to talk about how that can work and how you can sign up for that. IET also has access to AWS, and they've made it an easy process to get provisioned in AWS and to utilize resources at, I believe, a discounted rate through UC Davis. We also, through IET, have access to Microsoft Azure for the same thing, only Microsoft style. IET does offer a private cloud service. So if you want to run virtual machines, they do have a robust VMware infrastructure. So if you need your own virtual machines or virtual desktops, you can purchase resources through IET. And I also want to mention the robust information security options that they have. If you go to IETUCDavis.edu/security services and consultation, they do offer vulnerability management program options. They can do unit assessments, unit risk assessments, and vendor risk assessments. So if you have any security needs, if you have data needs that you're unsure of about the security, I encourage you to reach out to the ISO and talk to them, and they've been very helpful. So in addition, again, Carl went over this, docs.hbcucdavis.edu. That's a work in progress. It's always been a work in progress. The good thing about docs.hbcucdavis.edu is it's hosted in GitHub. So if anybody wants to help out with our documentation, it's just a pull request away. Our website is at hbcucdavis.edu. If you're interested in buy-in rates, you can go to rates or hbcucdavis.edu/rates. It gives rates for farm and for hive and for buy-in. I recommend if you're interested in rates that you contact me or email hbc-help@ucdavis.edu, and HBC help is will go into our ServiceNow queue, and you can inquire about any of the clusters that we maintain. I encourage you to go to Data Lab workshops that Carl mentioned, or datalab.ucdavis.edu/workshops. That'll give you a primer on how to connect to research computing through SSH, through Linux command line. If you want to learn more about HPC, I strongly encourage going to these workshops. And we're also working on more of a generic website. And this is also a work in progress, but I think this is a overview of all research computing on campus. Again, a work in progress at researchcomputing.ucdavis.edu. And now I'm going to turn it over to JP.
Thank you, Charles. That was an excellent presentation and an excellent demo. Hope everyone can hear me pretty well. Sometimes my laptop's a little goofy with the audio, but I too will share my screen and get underway with my portion of the discussion. So as we talked about earlier, high performance computing is a phenomenal tool, something that can be scary at first, and once you get used to it, it's not as bad. This is coming from someone like myself. So who am I? So I'm Dr. Graf. So I'm a hematopathologist here at the UC Davis Health Campus in Sacramento. And so hematopathology is the study of lymphomas and leukemia. So I look at bone marrows and lymph nodes and other biopsied material that might have those neoplastic processes in there, and predominantly use a microscope. The other hat that I wear is speaking of ASCII art, this is a nice ASCII art from earlier, where computer scientists really like to simplify the artwork form. And this is just all text that you can put into code or wherever you want to put it into. But anyway, happy Friday. So the other hat that I wear is clinical informatics. And so clinical informatics is a somewhat young and unique field of medicine. So I'm going to sit on my plinth here and tell you all about it briefly. So what these folks are and what I am is we are physicians who have gone through medical school in some form of residency, whether that's pathology in my case, family medicine, surgery, emergency medicine, etc. And then we spend an extra 2 years in a fellowship known as clinical informatics. And the point of this is to be certified by the American Board of Medical Specialties as a computer, geek to some degree. Now, by comparison to the other folks on this call, my computer skills are nowhere near as robust as Ian and Charles and Carl skills are. My day job is a little bit different than theirs. However, I know enough, as they say, to be dangerous. And so what's the whole point of having clinical informatics? So our goal is to analyze, design, and implement systems using the data structures we have in the health world. So this helps improve population health. It helps improve patient outcomes by improving patient care. It strengthens the clinical and patient relationships. And then, the overall concept here is you're going to be this organizer of all this data so that you can continue to push forward in that research space. Exclude my Zoom or my Teams meetings there. So with the clinical informatics part, we have a little specialty in the clinical computing architectures for the health campus. So the health campus, as you can imagine, the word HIPAA comes up pretty fast. And so when you want to do research on patient data, we want to give you a secure environment to do that. And so what we have here is the high-performance compute cluster for the UC Davis Health Campus, and that sits behind the hospital firewall, and it gives you access to other cloud services, not restricted just to its own HPC cluster. So it can connect out to Microsoft Azure, as mentioned earlier, as well as Amazon AWS, and both of those components have been allocated for HIPAA-compliant BAAs within this HPC environment. And so who's running this and how this is working. This is run by Kent Anderson, Jason Adams, Chris Lombardis, and a few others who have put this together. And I speak to you as a user of this service, not as a developer of this service. And this is their landing page. The most important part of this landing page is down here at the bottom of your screen, where it allows you to request a ServiceNow ticket to provision yourself one of these systems. These systems will have GPU and CPU power, usually about 8 gigabytes of CPU, or sorry, 8 gigabytes of GPU storage, and then you'll get up to 128 gigabytes of CPU RAM dedicated to that. And so within this environment, you can access Dave, which is our instance of Databricks, which has some precompiled notebooks in there to allow you to access some of our de-identified data sets. We also have the AWS HIPAA landing zone, which allows us, again, some AWS access. So if you want even more cloud compute, this is very nice. And one of the things that was mentioned earlier is about the uptime and this concept of having systems always available. So let me back up to this little image here. And one of the nice things about having a local HPC is that you can create instances that can live within your environment and not directly live within Amazon or Microsoft. So you don't have to have these systems constantly running, but if your HPC needs to use some features from Amazon or Azure, they can do that on an as-needed basis, which can be a little bit more cost efficient. So instead of provisioning an HPC with 20 GPUs that you might only use for 2 hours, you can go ahead and get that from something like Amazon to run that high compute component for you for that moment. So that's the background of what we have here on the Health Campus. So this is the landing page here. I'll put that in chat for everybody to get access to. If you want to reach out to me, that is my email address. And then I guess while we're here, I'll just take you to that website. So here's the health computing website, so we can read all about it. The same things I just showed off. Again, most importantly is the ServiceNow request that you see here that allows you to have access to these systems. And depending on what data you're provisioning, you might or might not need IRB, depending on if you're working with de-identified data, et cetera. And then once it's there, another instance of interacting with these systems that hasn't been discussed is this VS Code software. And so this is VS Code right here, this wonderful screen that you're looking at running a Jupyter notebook within that H2 environment. So you can see over here, it says ACE environment. That is what I'm connected to. And so I can run Python in a Jupyter notebook style platform right here. So if I want to compile this code, I can hit the play command and it will compile this code. And this will create a fictitious database of CVCs for us with some values of those CVCs averaged out here. The other really nice thing that this gives you access to, if I can put the right buttons here, yep, this is it, is the terminal. So just like we saw on Charles' demonstration, this is the terminal that is interacting with that virtual environment. So if I want to, list all the files in this directory, which I guess there's nothing in there, I can go back a directory, and then I'll do a LSA, and there's all my file directory structures within here. So I can explore it this way. There's also a little bit of a visual method to explore using VS Code, where I can actually go into the Remote Explorer that you see here, and I can tab that on and off and actually see some of my folders and structures that I have within the system. So it's another way to interact with it. I do think what Charles showed with using the VNC and giving users a graphical user interface, that is a huge advantage of using the on-demand service on campus. Unfortunately, we don't have anything like that on the Health Campus, so it is going to be using these types of systems either through an SSH protocol or something like VS Code to connect into it. But once you're connected, you can clone your GitHub repositories, put up a Docker, et cetera, and get these things running. And for the most of the dabbling that I do, I like that method because a lot of the Docker environments that you can host end up having a URL gateway that you can access. That again, it's behind the health system firewall, so it's not a public accessible address. But once you're within that firewall, you can access that graphical user interface hosted by your virtual machine to interact with it for whatever purposes that you are trying to achieve. So I'll end my discussion here, and I'll stop sharing my screen. We'll open it up to some questions from the group and from those that were here today. And I really appreciate everyone's time and attention to all this, because it's wonderful work and can be intimidating at first. And as Carl was saying, the workshops that the Data Lab offers are invaluable, not just for your own learning of how to interact with these systems, but more importantly, some of the connections you will make with that group. Because likely when you are in person in these meetings in Data Lab, you're going to bump into other folks trying to do the same thing you're trying to do, and you can likely leverage each other's help as you're going through these systems. So just know that it looks intimidating. It might be a little bit, but once you get onto the freeway or get onto the clusters, starting to interact with this stuff becomes easier with time. And so I encourage all those that are interested in doing this kind of work to dig in and jump in. I'll be quiet.
Thank you, everyone. This is the part of the session where the speakers take questions, and I was very excited to see that we had a lot of Q&A already going on in the chat. So if you use the raise your hand option, I can call on you if you have specific questions for the speakers. And you might have covered this already, but during registration, people were allowed to submit some questions. So maybe I can start with a question while people think about what they want to ask. There were a couple of questions regarding how to deal with confidential data. So how is it protected? Where can it be used? What systems are not allowed to like accept confidential data? So
sure, I guess I could take a stab at this one up front. You know, with confidential data that relies on healthcare data, that is something that the health systems high performance compute cluster can help with the security aspects of it. Like I said, you still will need IRB if you're going to be utilizing, you know, our patient data. So the collection process of that data, the transport of that process is all handled by your IRB. And how you're going to de-identify it, if you de-identify it, or if you keep it identifiable, that process must be cleared through that. There are a couple of committees if you're going to start doing artificial intelligence or machine learning work that leverages high performance compute. And there are some committees that oversee the data pools for that so that there isn't the risk that some of this data could then be reconstructed to identify the user. And so, you know, we are cautious on that. But, you know, like I said, if you're going to do health data, the ACE environment from the health campus is the best way to do it. And so that's my part there for that kind of data. But other protected data, I'll let the others sort of talk about.
So unfortunately for clusters on the UC Davis campus, we do not allow access to sensitive data on our systems. We're just not set up for that, and the hosting environments that we currently maintain our servers in is not set up to protect that sort of data. If you have those type of needs, I suggest it's information that IET can possibly help with their enhanced secure enclave. And I know that there are ways to bridge the gap between information in AWS securely and our clusters. I suspect that Secure Enclave also has compute resources in there, but I do stress that we are not set up for P3 and P4 data, also not set up for availability 3 and 4 data. We are just not at that place yet to be able to handle that.
For those of us who are not like well informed on the jargon, can you walk us through what like P1 through 4 data is?
Kind of. So I don't have them memorized, but so those are classifications that are defined by the College of the President, so UCOP. If you do a Google search for protection levels or availability levels, I can try that real quick.
Oh, okay.
Yeah, so there's a UC available classification guide that just came up. Availability, let's see, I'd say availability 4 is say building access systems, directory services like single sign-on email. So those need to be up These are critical and need to be up all the time. Availability level 3 needs to be up a lot of the time, but not as much as, say, a level 4, I believe. And that's a building management system, clinical trial management system. So these are things that need to be available rather than, say, HPC. HPC is commodity, cheap hardware. They don't need to be available. If one dies, then you can just run something else on another node. And then I can also look at UCOP protection levels. And
I think one of our colleagues from IT posted something in the chat too. If people are curious.
yes,
UC
yeah,
Davis.
thanks. Security data classification. So that helps. P4, sensitive identifiable human subject research data or research covered by certificate of confidentiality. Social security number, subset of PII. P3 is animal research protocols, attorney-client privileged information, that sort of thing.
Thank you. Any questions from the audience? It can be very general questions. I know we have a mix in the audience of people who are probably experienced already and people who are trying to get into HPC. So please ask your questions even if you think they're very basic. We have a question in the chat. Avinash is asking, what committee is required for utilizing patient data for artificial intelligence and machine learning applications, or is it just IRB approved? So I guess the question is IRB approval enough, or is there a different committee that also needs to approve the use of data for AI and machine learning work?
As you can imagine, at UC Davis, we like to have committees. And so there is an HDOC committee, HDOC, and that is spearheaded by Jason Adams. And so you will need to get IRB approval to pull the data and then utilize it. And then once it is in that process of the IRB, it should go to HDOC as part of that. So like if you've done an IRB and you want to work with cancer center patients, for example, there's a special document you have to fill out for cancer center, and they will approve it, and you add that to your IRB. And so HDOC's somewhat similar to that, where they'll look at your proposal, and then they'll add that document to your IRB. And so once you get the overall approval, then you are good to go. But HDOC is the facilitator of looking at your methods for doing AI and machine learning based work on healthcare data. And so that's one of the resources, so Jason Adams and Kent Anderson are two very, very wonderful resources to leverage when it comes to that data inquiry right there. And so a lot of times there are some pre-existing de-identified data sets that are in that Dave Databricks environment. And so that could be a discussion you have with them too. If you're looking for a certain cohort, it might exist already.
Thank you. Any more questions from our audience?
And another thing I will add to that when it comes to the data use, there is something called the UC Wide Data Warehouse, and this is all the UC campuses, and it is an OMOP standardized medical record database. So it's taking the EMR records from UC Davis, UC Irvine, UCLA, UCSF, San Diego, and compiling them to a large data set. So if you do want to do that kind of large population health, we have that data available. It's through a request through the UCOP. So you get requests from there, and then it has a not quite as swift as on demand, but it has a web portal that allows you to run Jupyter style notebooks on that data to run analysis on that. So know that exists, and that is de-identified data. So it's already been collected, so you don't have to have the IRB per se, because the data has already been collected on that. But you do need access to the UC wide data warehouse.
Thank you. Any other questions from our audience? All Any final comments from our speakers then?
Sure, I'll make
Thank
a
you for
final
attending.
comment. This is Ian, and
That's always
if
Ian.
you're in here and you're a PI and you're wondering what the hell does any of this mean, and you're like, PIs have a lot of stuff going on. It's been a long time since I was thinking about computers, and it was just like it's changed so much in recent years, and you're wondering what the hell does any of this mean? Send me an email. I'll catch you up. We can have a chat. I don't want everybody to do this.
Yeah.
I'm not sending this out to everybody. But if you're like PI level and you're confused, please talk to me.
I'll just ditto that. You can also reach out to Data Lab, come to the office hours. Like there's enough resources here combined with all of us to help get through that and get you up and running and, move the research forward.
All right, well, it looks like we exhausted all the questions. Thank you so much. It was a very informative session for everyone who participated. We really appreciate you taking the time to join us on your Friday morning. This session was recorded, so we will try to follow up early next week with an email to everyone who registered and give you access to the recording and resources and links to the trainings and office hours resources that Carl discussed. I want to invite you to go to the Team Research Forum page and register to receive updates on upcoming forums. We have 3 more this fall. We're going to have a session called DARPA 101. So if you've been curious about funding from DARPA and how do you work with DARPA, we're going to have a speaker who's going to join us remotely to answer all your questions. We're going to have a session with the mouse biology program to learn a little bit more about how you can work with them too. And we have a final session this fall focused on working with community groups and involving citizen and community science. So if you're interested in any of those, please register in our Team Research Forum page so you can get all the invitations and all the details. Have a wonderful weekend, and we will see you next time.